Welcome to Physics Calculation Center. As I told you last time, in our last video, I said we'll continue with acceleration. But today we'll be looking at uniform acceleration. Uniform acceleration. From the word uniform, you should know that this means something that is constant. You know when you go to school, you wear uniform to school. When you go to school, so that you and your mates can look the same. So that's the meaning of uniform. Uniform acceleration. Constant acceleration. The way we calculate uniform acceleration is different from the way we calculate the normal acceleration. The last time we met, we talked about acceleration as being velocity over time. But today we'll be looking at uniform acceleration. And when we are calculating uniform acceleration, we use equation of motion. There are three equations of motion. Three equations. So for this video, we'll be looking at the first equation of motion. We'll be looking at the first equation of motion. And the first equation of motion says first equation of motion. If you need to calculate uniform acceleration, you need to understand the equation of motion. If you understand the equation of motion, then it will be easy for you. We have velocity, the big V, the small u, plus AC. Okay. This is final velocity. Final velocity. This is initial velocity. Initial velocity. This is acceleration. Sometimes you might have deceleration because when a car is moving, let's say this is a car is moving, you say it is accelerating. This is acceleration. Acceleration. This is acceleration. But when the car is moving backwards, you call it deceleration. Deceleration. Or you call it negative acceleration. Negative acceleration. Okay, so we understand the basic things there. So this equation is called first equation of motion. V equals u plus at, where V is the final velocity, u is the initial velocity, a is the acceleration, and t is time. And this gives you the picture. Okay, quickly, I would want us to quickly look at this example. Quickly, let's look at this example. I am not going to clean this totally for proper continuation. Okay, so look at this. It says a train. Example. Okay. Example. It says a train has an initial velocity. A train has an initial velocity. Has an initial velocity. A train has an initial velocity of 44 meters per second, or 44 meters per second, and an acceleration of minus and an acceleration of minus 4 meters per second square. Of minus 4 meters per second square. Okay. After 10 seconds. After 10 seconds. Okay. And the question says a train. Okay. Okay, a train has an initial and an acceleration of its velocity. So it says we should calculate its velocity. Okay, and an acceleration of 4 after. A train has an initial velocity of 44 meters per second and an acceleration of its velocity. So what is its velocity after 10 seconds? What is its velocity after 10 seconds? Okay, so you can see the question now. So here, you know we cannot use our regular velocity over time. Here you have to use the equation of motion. So you do V, no, first thing is to get your parameter. What parameter are you given? Initial velocity. Solution. Initial velocity is what? 44 meters per second. Okay. Acceleration is what? Acceleration is minus 4 meters per second squared. I told you, I said negative acceleration means deceleration. That means it is coming back. Deceleration. So we have the deceleration here. And what else do we have? We have time, which is 10 seconds. Now it's easy for us now to calculate the velocity. It's easy for us to calculate the velocity now. So you use velocity, the first law of equation, velocity equals u plus at, u plus at, u plus at. We have the final velocity, which we are meant to find. So the initial velocity is 44. So we are looking for final velocity, which is v equals u, which is minus 4. Pardon me. The initial velocity is 44. Initial velocity is 44 plus initial velocity is 44 plus the acceleration is minus 4 and time given is 10 seconds. Is that okay? Now, so velocity now becomes 44 plus times minus is minus 4 times 10 is 40. So 44 minus 40 gives you 4, which is 4 meters per second. Which is 4 meters per second. You can see that it is clear now. From here we have our final velocity, which is v, our initial velocity 44, and our acceleration, which is minus 4 meters per second squared. Beautiful. So from here now, you understand how to employ the first equation of motion. So in our next video, we'll do more examples of this, and I'll see you then.